Okay, day 8 might be the day in which I bow out, at least from doing it with as few possible outside helps as well. Yeah. Basically, we need to find the shortest distances between each of these coordinates. That in itself is not a problem. I don't believe this is necessarily a travelling salesman problem, because we're specifically looking for the two. We're not trying to link them all up. We're just trying to link them all up to one other one at least. And then we need to know for each individual sort of set of them, how many have we linked in that set. So, I do need a set. So I've just been building read data, and that's bringing everything in. It's creating a point as a struct. That's F64, but it needs to be. There needs to be an easy way to make it part of a set, and F64 is not easy to make a set because hashing F64s is hard and not implemented by default, and putting F64s in a B tree is also hard because it can have a nan, not a number. Not a number is by definition not equal to itself and can't be ordered, which means it can't go in a B tree set. So, unless I implement equals myself, just knowing that there is no nan that's going to crop up here, these will need to be types that will implement. And that's going to ultimately impact my calculation of distance. So I'm going to have to convert all of my usizers to F64s. Which is not the worst thing in the world, it's just a bit of a pain. And I want F64s because the distance that comes back here, I mean, it could be F32s, but let's make 64s. The distance that comes back here is almost definitely not going to be a whole number, and I guarantee there will be an odd bug that if these get rounded, we'll have a problem. So that's fine, this will still return an F64. A vec of point is probably okay, but we might need to change this to a set. I'm going to import hash set preliminarily. So the first thing to do, I guess, is closest point, which is going to take a point, and it's going to take a slice of other points, and it's not going to return an option, it's just going to return a straight up reference to a point. It's possible that this is going to require some. No points are being moved actually. So let mute mindist F64 infinity is fine. 4 point in points if let mute closest point is going to be the first one. If self dot distance point is less than min distance, min dist is self dot distance closest point to point, and we're going to return closest point. Now the issue is that we need a lifetime. So this point is going to live tick A, tick A, This point is going to have the lifetime of the reference of slice of points, which actually might be a bit dangerous because we might be chopping and changing this slice. So actually what I want is I want a slice of references to points, and it's that reference that needs to live longer. Because this slice, we might drop at any time, but the point inside the slice is going to stick around, and that's the lifetime we want. The reason we might be chopping and changing this slice is because for every point, I'm going to create a slice of all the other points and go through. Cool. So, how do we go about part 1? So data is going to be a vec of point. It's going to return use size. And yeah, I think for now, these results are always going to be use sizes. What we're trying to return is the product of the largest 3 circuits, which is why we need some sets. So, what it's going to be is iterate through all points and find their nearest neighbor, link them together by checking each one for membership in a hash set. If one exists in a set, add the other. Otherwise, create a new set and add both points. Okay, so let mu all sets is going to be a vec of hash set of point. And then what we're going to do is we're going to iterate through for point in data iter enum, enumerate. That's going to give me I and point. Do I need to go through all of the other points? I do not need to go through all of the other points because by definition, if I'm on point 3, I've already checked point 1 and it is not closest to point 3. No, that's not how that works, is it? Do I need to find the minimum of all? Alright, okay, I need to find the absolute shortest distance between all of the points, I think. It's possible itertools is going to make an appearance here. Yeah, I need to know the absolute lowest distance there possibly is. Oh god. So that means I want to know the nearest neighbor for every single... Yeah, maybe we can do this in... This isn't necessarily too bad, actually. So, find nearest neighbor for each point. And that's fixed. It doesn't matter if things are connected together. What matters is that we do this in order. Okay. Build a map of neighbor, and then it's going to be nearest point. In fact, build a map of distance and then it's going to be origin point, nearest point. And actually, these are symmetrical, right? So what I want is a three-way map, because I want a map that has origin point, nearest point, and distance that's indexable. I think the reality is I want a map of origin, like distance is you know, trivial to calculate. Origin point, nearest neighbor. So, because these are symmetrical, are they? No, they're not. They're not symmetrical. So it doesn't matter. In which case I want distance, yeah. And I want a B. Is a B tree map ordered based on when you put it in? Given a key type with total order, which I'm assuming just means ord, as impl. Order map stores its entries in key order. Yeah, okay, great. So build a B tree map of type distance, and then a tuple of origin point, nearest point, and then iterate over map from smallest to largest. See if either point exists in a circuit, which is also going to be a map of points. If yes, add other point to circuit. In which case it's actually add both to circuit, because well, actually I only need to see if it's in a set of points. Makes a circuit. If yes, add both points to circuit, else create new set. Add both points to it. Okay, cool. So, for each point, let min distances is of type B tree set of F64, which I can't have as the key of a set. And it's not a set anyway, it's a B tree map. Yeah, this isn't gonna be good. Oh. Apparently you're fine. So I can't hang on. There. You know what? I don't. That's fine. So long as it doesn't complain later. It knows it's an F64. It's presumably perfectly happy with that. For each point, I want to do let neighbor be equal to point dot. What did I call it? Closest point. And it's going to be points. And slices. Is there concat on slice? I've already looked up slice. Use concat on slice of slices. Okay. So we're going to have a slice concatenated, and in it we're going to have two slices, which are going to be 0 up to, but not including I plus 1 to the end. Expected a range, got a range from. Yeah, this does definitely need so I need to index points based on where's blue there, and it's going to be points.length. What did I call it? Data. Let's call you points instead. That will make more sense. Okay. And let's make point not a vector, but a slice of point. And then we can index it. No? I mean, actually, oh, hang on, do I just need to do this? Points there, points there. And take you away. Point needs to be sized. Still not happy? Point needs to be of type clone. I don't want to clone. Fine, you know what? I'm assuming we cannot index without a value. Fuck it. It's going to be the same amount of work anyway, so... Well, it's kind of the same amount of work. What I want to do is do point.closest point on an array containing that one and this one, going from I up to points.length. Where do you... Where's the... That. Da-da-da. What's that blue one? Right. Outside the blue, I need function call, a bracket. Still aren't happy. Expected reference. I guess. Fuck yeah, I did want references. Because it. Can you do that? I assume that when I actually... Oh. Oh, you shouldn't be read to string anymore. I've made a read data, thank you very much. And then it's going to complain. That data is the wrong type. Yeah, okay. Okay. You live as long as self. That is technically true. Expected a point, found a ref point. Why? First off, get rid of you. Point is itself a ref point, so that's fine. Expected a ref point, found an array. Fine, I will do this manually. Left, neighbor, be that. Oh, you're still not happy. Oh, right. Sorry, I've just realised why. Expected reference. Right. Right, neighbor. I up to points.len, not inclusive. If not doing self, if point dot distance left neighbor less than point dot distance right neighbor, then let min point be equal to left neighbor, else oh, I can assign out of block. So let min let closest neighbor be equal to that, otherwise it's going to be right neighbor. Okay. So then I want to do, let some set is equal to and I want the set to contain, I actually want this to be either set contains close neighbor or it contains point. Find is going to return an option. Yep, that's fine. Are you my if let sum? You're my find. You're waiting for itself. Yeah, okay, fine. Let's do this one. So here we're going to add both points to existing sets. Here we will add both points to new set and push set into all sets. Set.insert. No. Don't care about minimum distances. Insert. Closest neighbor. Point needs to implement EQ and hash. Both of those are perfectly fine. We can do that. Cool. Happy? No, what do you need? Expected point found ref point. Ref. That's fine. Cool. No cloning going on here. Let mute new set. Here's a hash set new. Insert it, and push it into the new set. Great. So in theory, I now have a set of all sets. New What was I going to do? Right, find the nearest neighbour, build a B-tree map with distance. Okay, so I still need to min distances dot insert, and it's going to be point dot distance with closest neighbour, and then it's going to be point and closest neighbour. Okay, what don't you like about insert? 64 board. Right, okay, so whilst it's perfectly happy to have a B-tree map of F64, it isn't happy to then insert them. Oh, this is annoying. Let's have a little think. Oh, goodness me, that was a slog, but parts 1 and part 2 done. God. Basically, calculate all of this. The problem I had is I assumed that we only wanted to find the absolute closest junction to any given junction, as opposed to find all of the distances between all of the junction boxes and then go in order. And the thing which also saved it is this skip here. If this skip isn't there, it doesn't work, because you end up double counting, which means that somewhere in my set stuff is the thing. Anyway, then sort all the distances, so lowest to highest. In part 1, there's this funky thing in the rule about you can only have 1,000 connections in the real solution, 10 in the test. So, and a connection that is already connected still counts. So if you find 2 points and they're already in a set, or if you find a point that's already in a set, that still counts. And then basically go through, if they're both in one set, ignore them, carry on, that's already connected. If neither of them are in a set, create a new set, that's a new connection, stick it in. Otherwise, if they are both in separate sets, merge the 2 sets, and then you need to do some funky borrowing rules, and then otherwise just stick the point in the set that was found. And then take the sort by length, and specifically sort by length with a custom function to sort by B to A, which is effectively going to sort descending instead of ascending, which means the first 3 are the highest. Truncate the first 3, take the product. Part 2 is super simple. It's ignore the max number of connections, keep going until you have a set that has the same length as all of the points, i.e. all the points are in one set, and then return the product of the x-coordinates of the last 2 points that you put in. And that is it.